Dear student, in this video we will learn chapter number 3 triangles. If you have not subscribed my channel, please subscribe it today itself. Let's start. Exterior angle of a triangle. Here we have a triangle ABC. Now we will extend side BC. We will get here angle ACD. You can see one angle ACD outside the triangle. This angle is called as exterior angle of triangle ABC. And here angle ACB, you can see the angle which are marked as red arc, angle ACB. It is an interior angle of this triangle, but it is adjacent to exterior angle ACD. So here angle ACD, that is exterior angle, and angle ACB is adjacent to exterior angle ACD. Okay, now the remaining two angle A and angle B are called as remote interior angles for exterior angle ACD. Okay, this angle BAC. Okay, it is a remote interior angle, and here angle B ABC is remote interior angle. So in this figure, with respect to exterior angle ACD, angle A and angle B are remote interior angles of this triangle. Practice set 3.1. Here we have question number 1. In the figure, angle ACD is an exterior angle of a triangle ABC. Measure angle B equals to 40 degree. Measure angle A equals to 70 degree. Find the measure of angle ACD. Let's see solution of this question. Here given is measure angle BAC is 70 and measure angle ABC is 40 degree. Okay. Angle ACD is an exterior angle of a triangle ABC. Look at this figure. Here angle ACD is an exterior angle of this triangle, and we know measure of exterior angle is equals to sum of its remote interior angles. So what are the remote interior angles for exterior angle ACD? Angle A and angle B. Angle A and angle B are remote interior angles for exterior angle ACD. Therefore, measure of angle ACD is equals to measure angle BAC plus measure angle ABC according to remote interior angle theorem. Now measure angle ACD equals to, at the place of BAC we will write 70 and at the place of ABC we will write 40. So we will get here measure angle ACD equals to 70 plus 40, that would be 110 degree. So measure of angle ACD is 110 degree. Question number 2. In triangle PQR, measure angle P equals to 70 degree, measure angle Q equals to 65 degree, then find measure angle R. Let's see solution of this question. In triangle PQR, we know the sum of measure of all three angles of a triangle is 180 degree. Therefore, measure angle P plus measure angle Q plus measure angle R equals to 180 degree. Now we will substitute here measure of angle P as 70 plus measure angle Q, that is 65 degree, plus measure angle R equals to 180 degree. 70 plus 65 will be 135 degree, plus measure angle R equals to 180 degree. Now we will shift 135 degree to that side of equal to. So measure angle R equals to 180 degree minus 135 degree. Measure angle R equals to 180 minus 135 will be 45 degree. Question number 3. The measures of angles of a triangle are x degree, x minus 20 degree, x minus 40 degree. Find the measure of each angle. Let's see solution of this question. The measure of angles of a triangle are x degree, x minus 20 degree, x minus 40 degree. So here we have a figure, and you can see the measure of all three angles of a triangle are given in terms of x. We know the sum of measure of all three angles of a triangle is 180 degree. Therefore, x degree, that is the measure of first angle, plus x minus 20 degree, measure of second angle, plus x minus 40 degree, that is a measure of third angle, equals to 180 degree. Now here x plus x will be 3x, minus 20 minus 40 will be minus 60, equals to 180 degree. Now we will shift minus 60 degree to that side of equal to. So we will get 3x degree equals to 180 plus 60 degree. Therefore 3x degree equals to 180 plus 60 will be 240 degree. Now we will shift 3 to that side of equal to. So x degree equals to 240 upon 3. Now we will go for the simplest form of this fraction. We will get x equals to 80 degree. So here we got the measure of first angle, that is 80 degree. Now we will find the measure of second angle. What is second angle here? X minus 20 degree. Now we will substitute here value of x, that is 80. So we will get here 80 minus 20 degree, and 80 minus 20 is 60 degree. So measure of second angle is 60 degree. Now we will find the measure of third angle, and your third angle is x minus 40 degree. We will substitute here the measure of x, that is 80. So 80 minus 40 degree equals to 40 degree. So here we got the measure of all three angles of this triangle. Measure of first angle is 80, measure of second angle is 60, and measure of third angle is 40 degree. Question number 4. The measure of one of the angles of a triangle is twice the measure of its smallest angle, and the measure of the other is thrice the measure of smallest angle. Find the measures of the three angles. Let's see here solution of this question. Here we have a triangle. Okay, now we will assume here the measure of smallest angle of this triangle. Let the measure of smallest angle of triangle be x degree. Okay, that means measure of one of the angle of this triangle is x degree. Now look at the condition in this question. Measure of one angle is twice the measure of smallest angle. What is the measure of smallest angle here? X. So the measure of one angle would be twice of it, that is 2x. And the measure of other angle is thrice of the smallest. What is smallest here? X. So thrice of x is 3x. So measure of the remaining two angles will be 2x and 3x degree as per given condition. Now we know the sum of measure of all three angles of a triangle is 180 degree. Therefore measure of first angle plus measure of second angle plus measure of third angle equals to 180 degree. X plus 2x plus 3x will be 6x equals to 180. Now we will shift 6 that side. X equals to 180 upon 6. Therefore x equals to 30 degree. So here we got the measure of one of the angle of this triangle, that is 30 degree. So we will find the measure of second angle. Second angle is 2x. 2x means 2 into x, and x is 30. So 2 into 30, that is 60 degree. Now we will find the measure of third angle, and the measure of third angle is 3x. 3x means 3 into x. And what is the value of x here? 30 degree. So 3 into 30 equals to 90 degree. So here we got the measure of all three angles of this triangle, that is 30 degree, 60 degree and 90 degree. Now here we have the next question. In the figure, measure of some angles are given. Using the measures, find the values of x, y and z. Let's see the solution of this question. Measure angle TEN plus measure angle NEM equals to 180 degree because they forms linear pair. Okay, you can see this figure here. Angle this one TEN plus angle NEM This two angle forms linear pair, right? And we know the sum of measure of angles in a linear pair is 180 degree. Therefore, measure angle TEN plus measure angle NEM equals to 180 degree. Now we will substitute here measure of angle TEN, that is 100, plus y, that is NEM is given as y, equals to 180 degree. Therefore y equals to 180 minus 100 degree. Therefore y equals to 80 degree. Measure angle EMR plus measure angle EMN equals to 180 degree, because they also forms linear pair, right? Which two angle forms here linear pair? That is angle, this angle Z, and this angle, that is an angle having measure 140. That means angle EMR and angle EMN forms linear pair. Therefore sum of these two angle is 180 degree. EMR is given as 140 and EMN is denoted as Z. So 140 degree plus Z equals to 180. Therefore Z equals to 180 minus 140 degree. Therefore Z equals to 40 degree. Now in triangle ENM, angle X plus angle Y plus angle Z equals to 180 degree, because the sum of measure of all three angles of a triangle is 180 degree, correct? Now at the place of X we will write X, at the place of Y we will write 80, at the place of Z we will write 40 equals to 180 degree. Now we will add 80 degree plus 40 degree. You will get X plus 120 degree equals to 180 degree. Now we will shift 120 degree to that side of equal to. So we will get here X equals to 180 minus 120 degree. Therefore X equals to 60 degree. So we got here measure of X, measure of Y and measure of Z. So here X is 60 degree, Y is 80 degree and Z is 40 degree. Now here we have the next question. In the figure, line AB parallel line DE, find the measure of angle DRE and angle ARE using given measures of some angles. Okay, let's see the solution of this question. Here line AB parallel line DE and line AD is a transversal. Therefore, look at this figure. Therefore, angle BAD congruent angle EDA. Okay, these two angles will be congruent. The angles which are marked as red arc will be congruent. Do you know why? Because they are alternate angles formed by two parallel lines, and we know alternate angles formed by two parallel lines are congruent. Therefore angle BAD congruent angle EDA by alternate angle theorem. Okay, but angle BAD is given as 70 degree. You can look at this figure. This angle is given 70 degree. Therefore angle EDA will be also 70 degree. But angle EDA can also be written as angle EDR, right? EDR. Why? It's the same angle with different name, A dash R dash D. Now in triangle DRE, we know the sum of measures of all three angles of a triangle is 180 degree. Therefore measure angle EDR plus measure angle DER plus measure angle DRE equals to 180 degree. Now at the place of EDR we can write 70 plus DER, that is 40, plus measure angle DRE equals to 180. Now 70 plus 40 will be 110 degree plus measure angle DRE equals to 180 degree. Therefore measure angle DRE equals to 180 minus 110 degree. Therefore measure angle DRE equals to 70 degree. Now here you can look at this figure, angle ARE. Okay, you can see the angle ARE in this figure and angle DRE. forms linear pair. Therefore, sum of these two angles is 180 degree. Therefore, measure angle ARE plus measure angle DRE equals to 180 degree as they forms linear pair angles. Therefore, measure angle ARE plus 70 degree equals to 180 degree. Therefore, measure angle ARE equals to 70 degree will go that side. So 180 minus 70 degree. Therefore, measure angle ARE equals to 110 degree. Here we have the next question. In triangle ABC, bisector of angle A and angle B intersect at point O. If measure angle C equals to 70 degree, find measure of angle AOB. Here we have a figure. You can see angle C is given 70 degree. Let's see solution of this question. Okay, here ray AO bisect angle CAB. Okay, can you see the figure? AO is a bisector of angle CAB. It means angle CAO, you can see in the figure, angle CAO and angle BAO will be congruent. Okay, because AO is a bisector, it means it divides angle CAB in two equal angles. Therefore, angle CAO congruent angle OAB. Now we will assume angle CAO as x. Therefore, angle OAB will also x. So let angle CAO equals to angle OAB equals to x degree. That is equation number 1. Similarly, ray BO bisect angle CBA. You can look at this figure. BO is a bisector of angle CBA. Therefore, angle CBO. Can you see in this figure? Angle CBO and angle OBA will be congruent. So we will write here angle CBO congruent angle OBA. Now we will assume angle CBO as y degree. Therefore, angle OBA will also y degree. You can look at this figure. I have taken those two angles as y degree. Okay, so let angle CBO equals to angle OBA equals to y degree. That is equation number 2. Now here measure angle CAB. You can look at this figure. Here angle CAB, this angle CAB is sum of this angle, that is CAO, and angle OAB. Sum of these two angles will be CAB. So measure angle CAB equals to measure angle CAO plus measure angle OAB according to angle addition property. Therefore, measure angle CAB equals to x plus x from equation number 1. Therefore, measure angle CAB equals to 2x degree. That would be equation number 3. Now, similarly, measure angle CBA equals to y plus y, that is 2y degree, and that would be equation number 4. Now we will take the larger triangle. In triangle CAB, we know the sum of measure of all three angles of a triangle is 180 degree. Therefore, measure angle ACB plus measure angle CAB plus measure angle CBA equals to 180 degree. Now at the place of ACB, we will write 70 degree, and at the place of CAB, we will write 2x, and at the place of CBA, we will write 2y equals to 180 degree. Now you can see the second and third term, 2x plus 2y. There is 2 is common, right? So we will write here 70 degree plus 2 in a bracket x plus y. You can see that I have taken 2 as a common equals to 180 degree. Now we will shift 70 degree to that side. So 2 into x plus y equals to 180 minus 70. Therefore, 2 into x plus y equals to 110 degree. Now we will shift 2 to that side of equal to. So x plus y equals to 110 upon 2. Therefore, x plus y equals to 55 degree. Now in triangle OAB, measure angle AOB plus measure angle OAB plus measure angle OBA equals to 180 degree. as the sum of measure of all three angles of a triangle is 180 degree. Now we will copy AOB as it is. At the place of OAB, we will write x. You can look at this figure. OAB is x, that was according to assumption. And at the place of OBA, we will write y equals to 180 degree. Now x plus y, the value of x plus y, already we have calculated it. What was that? 55. So measure angle AOB plus 55 degree equals to 180 degree. Well, now we will set 55 degree to that side. Therefore measure angle AOB equals to 180 degree minus 55 degree. Therefore measure angle AOB equals to 125 degree. Question number 8. In the figure, line AB parallel line CD and line PQ is a transversal. Ray PT and ray QT are bisectors of angle BPQ and angle PQD respectively. Prove that measure angle PTQ equals to 90 degree. Proof. Look at this figure. Here ray PT is a bisector of angle BPQ. Therefore angle BPT congruent angle TPQ. Okay. Now we will consider angle BPT as x degree. Therefore angle TPQ will also x degree as they are equal. So let angle BPT equals to angle TPQ equals to x degree. Consider this one as equation number 1. Look at this figure. Which two angle I have taken as x? Angle BPT, angle TPQ. Now similarly, look at this figure. Here ray QT is a bisector of angle PQD. It means it divides angle PQD in two equal angles. They are angle PQT and angle TQD, and both will be congruent as ray QT is a bisector of angle PQD. Now we will take angle PQT as y degree. So the angle TQD will also y degree as they are equal. Let angle PQT equals to angle TQD equals to y degree. It will be equation number 2. Look at this figure. I have taken angle PQT and angle TQD as y degree. Now line AB parallel line CD and line PQ is a transversal. Look at this figure. Here line AB is parallel to line CD and line PQ is a transversal. Therefore measure angle BPQ plus measure angle PQD equals to 180 degree according to interior angle theorem. We know that interior angles are supplementary when the lines are parallel. Now at the place of BPQ, we can write angle BPT plus angle TPQ. You can look at this figure. Angle BPQ is sum of two angles. They are BPT and TPQ. Similarly, angle PQD can be written as measure angle PQT plus measure angle TQD according to angle addition property. Now at the place of BPT, we can write x from equation number 1. At the place of TPQ also we can write x from equation number 1. And at the place of PQT, we can write y. At the place of TQD, we will write y using equation 1 and 2. So we will get here 2x plus 2y equals to 180 degree. Now we will take 2 as a common. So we will get 2 in a bracket x plus y equals to 180. Therefore x plus y equals to 180 upon 2 equals to 90 degree. Therefore the value of x plus y equals to 90 degree. We will take this as equation number 3. Now we will take triangle PTQ. Look at this figure. Okay, you got triangle PQT. Here we are going to apply sum of measure of all three angles of a triangle is 180 degree. Therefore measure angle PTQ plus measure angle TPQ plus measure angle TQP equals to 180 degree as per property of angles of a triangle. At the place of PTQ, we will write PTQ. At the place of TPQ, okay, we will write x. Look at the figure. This angle is x and angle TQP will be replaced by y. Okay, you can see in the figure this angle is y equals to 180 degree. This is from 1 and 2. Now we will substitute here the value of x plus y, and you can see the value of x plus y is 90 degree from equation 3. So we will get measure angle PTQ plus 90 degree equals to 180 degree. We will shift now 90 degree to that side of equal to. So we will get here measure angle PTQ equals to 180 minus 90 degree. Therefore measure angle PTQ equals to 90 degree. So we proved it over here how the measure of angle PTQ is 90 degree. Question number 9. Using the information given in the figure, find the measure of angle A, angle B and angle C. Let's see the solution of this question. Look at this figure. Here angle B and 70 degree are vertically opposite angle, and we know vertically opposite angles are congruent. Therefore angle B equals to 70 degree. Now look at this figure. Here angle C and 100 degree forms linear pair. And we know angles in a linear pair are supplementary. Therefore, angle C plus 100 degree equals to 180 degree angles in a linear pair. Now we will shift 100 to that side. Angle C equals to 180 minus 100 degree. Therefore, angle C equals to 80 degree. Now look at this figure. Here angle A and B and C are the angles of a triangle, and we know sum of measure of angles of a triangle is 180 degree. Therefore angle A plus angle B plus angle C equals to 180 degree. Now at the place of A we will write A, and B can be replaced by 70 degree, and angle C can be replaced by 80 degree equals to 180. Now 70 plus 80 will be 150 equals to 180. So angle A plus 150 equals to 180. Therefore angle A equals to 180 minus 150. Therefore angle A equals to 30 degree. Here we have question number 1. In each of the examples given below, a pair of triangle is shown. Equal parts of triangle in each pair are marked with the same sign. Observe the figures and state the test by which triangles in each pair are congruent. Okay, you can see here we have two triangles, and you can see that side AB and side PQ got a same kind of mark. Therefore side AB congruent to side PQ. Okay, and here side BC and side QR got a same kind of mark. Therefore side BC congruent to side QR, and side AC and side PR got a same kind of mark. Therefore side AC congruent to side PR. So you can see that here both the triangles have equal sides. It means all three sides of both the triangles are congruent to each other. Therefore these two triangles are congruent by SSS test. Let's see question number 2. Here we have two triangles, and you can see that some identical marks are shown in this figure. Okay, you can see here side LM and side XY got a same kind of mark. Therefore side LM congruent to side XY. And here you can see in this figure angle LMN and angle XYZ got a same kind of mark. Therefore angle LMN congruent angle XYZ. Okay, and side MN and side YZ got a same kind of mark. Therefore side MN is congruent to side YZ. Okay, therefore these two triangles are congruent by SAS test. Here we have question number 3. You can see that some identical marks are shown in the figure itself. Okay, you can see here angle P and angle S got a same kind of mark. Therefore angle P congruent angle S. And you can see here side PR, the side, and side SU got a same kind of mark. Therefore side PR congruent side SU. And here angle R and angle U got a same kind of mark. Therefore angle R congruent angle U. So here angle P congruent to angle S, and side PR congruent to side SU, and angle R congruent to angle U. Therefore, these two triangles are congruent by angle side angle test. Now here we have question number 2, and you can see that both the triangles are right angle triangle. Okay, because here angle M is 90 degree and angle T is 90 degree. So both the triangles are right angle triangle, and you can see that here side LN congruent to side PR, right? Because they got a same kind of mark, and these two sides are known as hypotenuse of both the triangles. So hypotenuse of both the triangles are congruent to each other. Okay, because of that identical mark. And here side LM congruent to side TP. Therefore, these two triangles are congruent by hypotenuse side test. Here we have question number 2. Observe the information shown in pairs of triangles given below. State the test by which the two triangles are congruent. Write the remaining congruent parts of the triangles. Okay, you can see that here it is given that angle ABC congruent to angle PQR. Okay, you can see here these two angles got a same kind of mark. It's a given these two angles are congruent, and side BC congruent to side QR. Okay, this side BC congruent to side QR, it's a given, and angle ACB congruent angle PRQ, this angle. Okay, angle ACB, okay, and angle PRQ got a same kind of mark, so these two angles are congruent. Okay, therefore these two triangles are congruent by angle side angle test. Okay, so what we will write here, angle side angle test. Okay, now look at over here it is given that angle BAC, this angle, okay, angle BAC congruent to dash, angle BAC is congruent to angle QPR. Okay, why these two angles are congruent? Because they are angles of congruent triangle. Similarly here side AB, okay, this side is congruent to dash, so side AB is congruent to side PQ, as they are sides of congruent triangles. Here dash is congruent to PR. Where is the PR? Over here, this side. Side PR is congruent to side AC, right? Side PR is congruent to side AC because they are sides of equal triangles. Here we have question number 2 from the information shown in the figure. Okay, in triangle PTQ and in triangle STR, side PT congruent to side ST. Okay, you can see here side PT and side ST got a same kind of mark, so these two sides are congruent to each other, it's a given, right? And here angle PTQ congruent to angle STR, angle PTQ, this angle, and angle STR are congruent because they are vertically opposite angle. Okay, and side TQ congruent to side TR. Okay, you can see this side TQ and side TR are congruent to each other, it's a given. Therefore these two triangles are congruent by side angle side test. So what we will write here, side angle side test. Now look at here, angle TPQ. Where's angle TPQ? This angle. Okay, angle TPQ is congruent to which angle? Angle TPQ is congruent to angle PSR. Okay, angle PSR. So what we will write here, angle PSR, TSR. Okay, and angle TRS is congruent to which angle? Angle TRS, this angle. Okay, angle TRS is congruent to angle PQT. Okay, so what we will write here? Which angle we will write over here? PQT or TQP, as they are angles of congruent triangle. And side PQ, okay, this side PQ is congruent to which side? Side RS. So which side we will write here? Side RS or seg RS, as they are sides of congruent triangles. Now here we have next question. From the information shown in the figure, state the test assuring the congruence of triangle ABC and triangle PQR and write the remaining congruent parts of the triangles. Okay, let's see the proof of this. You can see that here both the triangles are right angle triangle. Okay, so here this side BC, which is the hypotenuse of this triangle, is congruent to side PR of triangle PQR. That means the hypotenuse of both the triangles are congruent. So hypotenuse BC congruent to hypotenuse PR. It's a given. You can see this, they got the same kind of mark. Okay, and here side AB, this side AB and side PQ are congruent because they got a same kind of mark. And angle BAC, okay, this angle BAC is congruent to angle PQR because they have same measure, both have same measure, that is 90 degree. Okay, therefore triangle ABC congruent triangle PQR by hypotenuse side test. So I have proved it over here. These two triangles are congruent by hypotenuse side test. After proving those two triangles congruent, okay, first it was asked find out by which test these two triangles are congruent, right? So these two triangles are congruent by hypotenuse side test. And now you have tried the remaining congruent parts of the triangles. Okay, parts means you know that every triangle has 6 parts, 3 angles and 3 sides. Now we have to find out remaining parts which are congruent in this figure. Okay, so here seg AC, okay, seg AC congruent to seg QR, okay, this side seg AC and seg QR will be congruent as they are sides of congruent triangle. Okay, and here angle ABC congruent angle QPR, angle ABC, this angle, okay, you can see in this figure angle ABC is congruent to angle QPR, okay, because of CACT. And angle ACB, okay, you can see in the figure angle ACB congruent to angle QPR because of CACT. Now here we have question number 4. As shown in the figure, in triangle LMN and triangle PNM, LM and PN are equal, LN equals to PM, and write the test which assures the congruence of two triangles and write their remaining congruent parts. What we have to find out, by which test these two triangles are congruent. Okay, and afterward you have to write the remaining congruent parts of these two triangles. So let's see the proof of this. In triangle LMN and triangle PNM, side LM congruent to side PN, side LM, okay, the side congruent to side PN because they got a same kind of mark, it's a given. Okay, and side LN congruent to side PM, okay, this side LN, okay, this side is congruent to side PM, okay, this side, it's a given. Side MN congruent to side MN, okay, here side MN congruent to side MN, it is side of both the triangles, right? It is side of triangle LMN as well as it is side of triangle PMN. So it is side of both the triangles, so we can say these two sides are congruent as they are same side of both the triangles. So these two triangles are congruent by side test. Okay, so I have proved it over here. Okay, I have proved it over here. These two triangles are congruent by side, side, side test, and afterward we have tried here remaining congruent parts of those two triangles. Okay, so look at over here. You can see in this figure angle LMN congruent to angle PNM, right? Which two angles? Angle LMN, this angle, okay, congruent to angle PNM because of CACT. An angle, you can see in this figure, angle MLN congruent to angle NPM, right? This angle, angle L congruent to angle P, that is angle MLN congruent to angle NPM CACT. Okay, you can see in this figure here angle LNM congruent angle PMN, this angle. Okay, I'm talking about this angle, that is angle LNM congruent to angle PMN by CACT. Here we have question number 5. In figure, seg AB congruent seg CB, seg AD congruent seg CD. Prove that triangle ABD congruent triangle CBD. Let's see proof of this question. In triangle ABD and triangle CBD, look at this figure. Here side AB and side BC got a same kind of mark. Okay, side AB and side BC got a same kind of mark. Therefore, side AB congruent side CB. Look at this figure. Here, side AD and side CD got a same kind of mark. Okay, side AD and side CD got a same kind of mark. Therefore, side AD congruent side CD. Look at this figure. Here, seg BD is a common side. It is a side of both the triangle. I'm talking about this segment. Look at over here, seg BD. Okay, it is a side of both the triangles. Therefore, side BD congruent side BD. Okay, because common side. Therefore, triangle ABD congruent triangle CBD by SSS test. Here we have question number 6. In figure, angle P congruent angle R and seg PQ congruent seg RQ. Prove that triangle PQT congruent triangle RQS. Let's see the proof of this question. In triangle PQT and triangle RQS, look at this figure. Here angle QPT congruent to angle QRS, right? Which two angles will be congruent over here? This angle, angle QPT congruent to angle QRS. How we came to know? You can see the given part. It is given angle P and angle R are congruent. Okay, so I can say here angle QPT congruent angle QRS. Look at this figure. Okay, you can see here side QP, the side is congruent to side QR. Okay, how we came to know? Look at the given part. It's a given that seg PQ congruent seg RQ. So we can write here seg PQ congruent seg RQ. Okay, now look at this figure. Here angle PQT, okay, congruent to angle RQS. Alright, you can see that. You can say angle PQT or you can say angle RQS. It is same angle, okay, with two different names. So I can say that here angle PQT congruent angle RQS. It's a common angle, same angle. Therefore, triangle PQT congruent triangle RQS by angle side angle test. Okay, these two triangles are congruent by angle, okay, angle, this angle side angle, okay, angle side angle test. Here we have question number 1. Find the values of x and y using the information shown in the figure. Find the measure of angle ABD and angle ACD. let's see the solution of this question. In triangle ABC, seg AB congruent seg AC. Look at this figure. In triangle ABC, seg AB and seg AC are congruent, and we know that if two sides of any triangles are equal, if any two sides of a triangles are equal, then the angle opposite to them will also equal. So let's see what is the angle opposite to side AB and side AC. Can you see? The angle ABC and angle ACB will be congruent, right? Angle ABC congruent angle ACB according to isosceles triangle theorem. Why these two angles are equal? Because they are angles opposite to equal sides. Okay, look at this figure here. Angle ACB is 50 degree, it's a given. Therefore angle ABC equals to 50 degree, and you can see that in this figure angle ABC is denoted with the letter X. Can you see? Angle ABC is denoted with letter X. So here the value of X is 50 degree. In triangle DBC, seg DB congruent seg DC, it's a given. Look at this figure. Okay, you can see triangle DBC in this figure. Here seg BD and seg DC are congruent, right? You can see the identical marks are given on those two sides. It means these two sides are congruent. And we know that if two sides of any triangles are equal, then the angle opposite to them will also equal. So let's see in this figure angle opposite to those two equal sides. Okay, can you see that angle DBC and angle DCB are the angles opposite to those two equal sides. Therefore angle DBC congruent angle DCB according to isosceles triangle theorem. Okay, look at this figure. In this figure angle DBC is 60 degree. Okay, so angle DBC is 60 degree. If angle DBC is 60 degree, then angle DCB will also 60 degree. And you can look at in this figure angle DCB is denoted with the letter Y, right? And the measure of angle DCB is 60 degree. Therefore the value of Y will be 60 degree. Angle ABD equals to angle ABC plus angle CBD. You can look at this figure here. Angle ABD, this angle, right? This angle is equals to angle ABC plus angle DBC, right? According to angle addition property. Therefore angle ABD equals to 50 degree plus 60 degree. At the place of ABC we will write 50 degree, right? Angle ABC is X and X is 50, and at the place of CBD we will write 60. Therefore angle ABD equals to 50 degree plus 60 degree. Therefore angle ABD equals to 110 degree. Similarly angle ACD, you can see in this figure angle ACD is sum of two angles, right? This angle ACD is sum of angle ACB and angle DCB according to angle addition property. Therefore angle ACD equals to 50 degree plus 60 degree, right? At the place of ACB we will write 50, and at the place of DCB we will write 60, right? And therefore angle ACD equals to 110 degree. So here we got the value of X, that is 50 degree. We got the value of Y, that is 60 degree. Angle ABD is 110 degree and angle ACD is also 110 degree. Here we have question number 2. The length of hypotenuse of a right angle triangle is 15. Find the length of the median of its hypotenuse. Let's see the solution of this question. Length of hypotenuse of a right angle triangle. How much it is given? It's given here 15. Right? You can see here length of hypotenuse of this triangle is given here 15. Okay. And what we have to find out? Length of median, which is drawn to the hypotenuse. And we know that in a right angle triangle, the length of the median on the hypotenuse is half of the length of the hypotenuse. Okay, the median which is drawn to the hypotenuse have the length half of the length of the hypotenuse. So here length of the median on the hypotenuse is equals to half of the hypotenuse. And what is the hypotenuse? How much it is given? 15. So half of 15. Therefore length of the median on the hypotenuse is equals to 7.5 units. Okay, so make a note. The length of median drawn to the hypotenuse is always equals to half of the length of the hypotenuse. Now here we have question number 3. In triangle PQR, angle Q is 90 degree, PQ is 12, QR is 5 and QS is median. Find the length of median QS. Okay, let's see the solution. Okay, you can see in this figure seg QS is median of this right angle triangle, and here PR is the hypotenuse, correct? And we know the length of median is half of the hypotenuse. So here QS will be half of the hypotenuse PR, but the length of PR is not given. So first we will find length of PR. Okay, so in triangle PQR, okay, you can see in triangle PQR, angle PQR is 90 degree. Now here we are going to apply theorem of Pythagoras to get the length of side PR, and we know the square of hypotenuse is equals to, you can see PR is hypotenuse, square of hypotenuse is equals to square of one side PQ square plus square of other side, that is QR square. Therefore PR square equals to, you can see the value of PQ, it's given 12. So at the place of PQ we will write 12. So we will get here 12 square plus QR. What is value of QR? You can see in this question it is given 5. So at the place of QR we will write 5. So 5 square. So PR square equals to square of 12 is 144 plus square of 5 is 25. Therefore PR square equals to 169. Therefore PR equals to root of 169. Therefore PR equals to, what is the root of 169? 13. So PR is 13. So I got the length of hypotenuse. Now I can find the median. Okay, let's see. Okay, you can see in this figure PR is 13 and we have to find out the QS. And we know in a right angle triangle the length of the median on the hypotenuse is half of the length of the hypotenuse. Okay, so length of median QS is half of the hypotenuse, that is PR. Okay, therefore QS equals to 1 upon 2 into, what was the value of PR? It's 13. So half of 13. So QS equals to 6.5 units. So we got the length of median. Now here we have the next question. In the figure 3.38, point G is the point of concurrence of medians of triangle PQR, and if GT is 2.5, find the length of PG and PT. Let's see the solution of this question. Okay, centroid divides each median in the ratio 2:1. What do you mean by centroid? Centroid is what? It is a point where all medians meet each other, and you can see in this figure all the medians meet each other at point G. So point G is the centroid of a triangle. Okay, you can see G is the centroid, and what centroid does, it divides median in the ratio 2:1. You can see in this figure G divides PT in two parts. The first part is PG and second part is GT, and you can see that BG is bigger than GT. Okay, so the ratio of PG and GT is 2:1. So what we will get here, length of PG upon length of GT equals to 2 upon 1. Okay, now what we will do, we will substitute here the value of GT, and what is the value of GT? It's 2.5. You can see here the value of GT is given here 2.5. So we will substitute here value of GT. So we will get here length PG upon 2.5 equals to 2 upon 1. Now we will go for cross multiplication. We will shift 1 that side, left hand side of equal to, and 2.5 to the right hand side of equal to. So what we will get? Length PG into 1 equals to 2 into 2.5. And length PG into 1 will be length PG. You can multiply any number with 1, you will get the same thing. And 2 into 2.5 gives us 5. So 5 centimeter. So here the length of PG is 5 centimeter. Okay. Now we have to find out here PT. Okay, you can see in this figure PT is sum of two segment PG and GT. If I'll add PG with GT, we will get length of segment PT. Therefore, length PT equals to length PG plus length GT. Since P dash G dash T, because P G T are collinear points. Therefore, at the place of PG we will write 5, and at the place of GT we will write 2.5, and 5 plus 2.5 gives us 7.5. Therefore, length PT equals to 7.5 units. Here we have question number 1. In figure, point A is on the bisector of angle XYZ. If AX equals to 2 cm, then find AZ. Let's see the solution of this question. Point A lies on the bisector of angle XYZ. Okay, you can see in this figure, ray YA is the bisector of angle XYZ, and point A lies on this angle bisector. It's a given. Correct. So according to angle bisector theorem, what is angle bisector theorem? If any point lies on the angle bisector of any angle, if any point lies on the angle bisector of any angle, then that point will have the same distance from the sides of an angle. So you can see in this figure, okay, A is equidistant from sides of angle XYZ. So look at in this figure, here seg AX and seg AZ, okay, represent distance of point A from side YX and side YZ. So here distance AX and distance AZ will be equal. Okay, here seg AX equals to seg AZ. Do you know why? Because A lies on the angle bisector. Okay, but here AX is 2 cm. It's a given. Okay, here seg AX is 2 cm. It's a given. You can see over here in the question. AX is 2 cm. If AX is 2 cm, then AZ will also 2 cm, since AX and AZ are equal. Here we have question number 2. In the figure, angle RST equals to 56 degree, seg PT perpendicular to ray ST, seg PR perpendicular to ray SR, and seg PR congruent seg PT. Find the measure of angle RSP. State the reason for your answer. Let's see the solution of this question. Okay, what is given here? Seg PT perpendicular to ray ST, and seg PR perpendicular to ray SR, and seg PR congruent to seg PT. This information is given. Okay, you can see in this figure, seg PT and seg PR are equal. That means point P has same distance from side ST and side SR. And if any point has same distance from sides of any angle, then that point will lie on angle bisector. Okay, point P will lies on angle bisector of angle TSR, since PT and PR are equal. Okay, it means ray SP is a bisector of angle TSR. Okay, when you say P lies on the angle bisector of this angle, it means you are saying that ray SP is a bisector of angle TSR. Therefore, angle RSP, okay, you can see in the figure, angle RSP is half of measure angle RST. Okay, since SP is a bisector, Therefore angle RSP equals to 1 upon 2 into, what is the measure of angle RST? It is given, okay, you can see it is given 56 degree, so half of 56 degree. Therefore angle RSP equals to 28 degree. Here we have question number 3. In triangle PQR, PQ equals to 10 centimeter, QR equals to 12 centimeter, PR equals to 8 centimeter. Find out the greatest and the smallest angle of the triangle. Okay, length of all three sides of this triangles are given, and what we have to find out, the greatest angle and the smallest angle of triangle PQR. Let's see the solution of this question. Here PQ is 10 centimeter, QR is 12 centimeter, and PR is 8 centimeter. It's a given, correct? Now what we will do, we will arrange given length in descending order, that is 12, 10 and 8. 12, 10, 8. 12, 10 and 8 we will arrange in descending order, greatest to smallest. So 12 is greater than 10 and 10 is greater than 8. Now with the help of this length, we can arrange sides of this triangle in descending order. You can see that 12 centimeter is the length of QR. So here we will write QR greater, and 10 centimeter is the length of PQ, and 8 centimeter is length of PR. So we will get here QR is greater than PQ and PQ is greater than PR. That means QR greater than PQ greater than PR. Okay. Now we know that angle opposite to greater side is greater. Angle opposite to greater side is greater. So which side is greater over here? QR. Can you see in this figure QR? Side QR. Which angle is opposite to side QR? You can see that angle P. Angle QPR is opposite to side QR. So we will write here angle QPR greater than, now what is the next side over here? PQ. Okay. Can you find PQ in this figure? Which angle is opposite to PQ in this figure? Angle R. Angle PRQ. So we will write here angle PRQ. And next side is PR, right? And which angle is opposite to side PR? Look at in this figure, which angle is opposite to side PR? Angle Q, that is angle PQR. Okay, so angle QPR is greater than angle PRQ is greater than angle PQR. So we had arranged those angles with the help of those sides, okay, using angle opposite to greater side is greater. Okay, so now we have arranged those angle in descending order. So now I know which angle is greater. Which angle is greater? Which angle is greater over here? Angle QPR is the greatest angle, and angle PQR is the smallest angle of this triangle. So here angle QPR is the greatest angle of triangle PQR, and angle PQR is the smallest angle of triangle PQR. Here we have the next question. In triangle FAN, angle F equals to 80 degree, angle A equals to 40 degree. Find out the greatest and the smallest side of the triangle and state the reason. Okay, let's see the solution of this question. Okay, now here we are going to use one important property. Side opposite to greater angle is greater. Side opposite to greater angle is greater, and side opposite to smaller angle is smaller. You can see that in this triangle measure of two angles are given. Okay, that is angle F and angle A. Angle N is missing. So what we will do over here, we will find measure of angle N. Do you know why we need to find measure of angle N? To know that angle N may be greater than the remaining two, or it may be smaller than the remaining two. Okay, that's why we need to find out measure of angle N to confirm that whether N is greater than the remaining two angles or it may be smaller than those two angles. Okay, so we will find measure of third angle using the sum of measure of all angles of a triangle is 180 degree. So angle F plus angle A plus angle N equals to 180 degree. Okay, therefore 80 degree plus 40 degree plus angle N equals to 180 degree. Now we will add 80 degree with 40 degree, we will get 120 degree plus angle n equals to 180 degree. Now we will shift 120 degree to that side. So we will get here angle n equals to 180 minus 120. Therefore angle n equals to 60 degree. So measure of third angle is 60 degree. Now we are very sure about the greatest angle and smallest angle of this triangle. Okay, so now what we will do, we will arrange those degree in descending order, greatest to smallest. So we know that 80 degree is greater than 60 degree and 60 degree is greater than 40 degree. Now with the help of these measures, we will arrange those angles in descending order. 80 degree is measure of angle F, so angle F is greater than 60 degree is measure of angle N, so angle N, and 40 degree is measure of angle A. Okay, so we had arranged those angle in descending order. Now we know that the side opposite to greater angle is greater and side opposite to smaller angle is smaller. So which angle is greater among this three angle? Angle F. And which is side opposite to 80 degree? AN. Okay, so AN is greater than angle N is 60 degree, right? And what is side opposite to angle N? Which side is opposite to angle N? FA. So we will write there FA greater than side opposite to angle A, that is FN. Okay, according to this property, side opposite to greater angle is greater. Okay, now look at over here. Now we know that the greatest side and smallest side of this triangle. Here seg AN is the greatest side of this triangle and seg FN is the smallest side of this triangle. So seg AN is the greatest side of triangle FAN and FN is the smallest side of triangle FAN. Now here we have the next question. Show that an equilateral triangle is equiangular. Okay, what is given here? Triangle is equilateral and we have to prove it is equiangular triangle. Okay, you can see here we have a triangle PQR. Okay, it is an equilateral triangle. Equilateral triangle means triangle having all three sides equal. So you can see that all sides have got a same mark in this figure. So given is triangle PQR is an equilateral triangle. What we have to prove? Triangle PQR is an equiangular triangle. Equiangular triangle means equal angle triangle. It means we have to prove here angle P congruent angle Q congruent angle R. If all three angles will be congruent to each other of this triangle, then we can say that this triangle is an equiangular triangle. So let's see the proof of this question. In triangle PQR, you can see in this figure, side PQ congruent to side PR. Okay, side PQ congruent to side PR, correct? Why these two sides are congruent? Sides of an equilateral triangle. And we know that if two sides of any triangles are equal, if any two sides of any triangles are equal, then the angle opposite to them will also equal. So what are the angles opposite to those two sides? Angle opposite to side PQ and angle opposite to side PR. Okay, so angle Q is opposite to PR and angle, you can see in this figure, angle Q is opposite to PR and angle R is opposite to PQ. Okay, these two angles are opposite to those two equal sides. So angle R equals to angle Q according to isosceles triangle theorem. Okay, got it? Why these two angles are equal? Because they are opposite to equal sides. Similarly, you can see in this figure, side PQ is congruent to side QR. Okay, seg PQ congruent to seg QR because sides of an equilateral triangle. So the angle opposite to side PQ and side QR will be equal. So let's see the angles opposite to side PQ and QR. Can you see side opposite to angle PQ, angle opposite to side PQ and QR? Angle P and angle R, correct? So angle R congruent to angle P according to isosceles triangle theorem, and that is equation number 2. Look at equation 1. Okay, look at your equation 1. What is given in equation number 1? Angle R congruent to angle Q, and equation 2 is R congruent to P. So here angle Q and angle P both are congruent to same angle R. It means all three angles are congruent to each other. So angle R congruent to angle Q, congruent to angle R. This we got from equation 1 and 2. Now all three angles of this triangles are equal, correct? All three angles of this triangles are equal. Therefore, triangle PQR is an equiangular triangle. Here we have next question. Prove that if the bisector of angle BAC of triangle ABC is perpendicular to side BC, then triangle ABC is an isosceles triangle. So first we will make a triangle ABC. You can see here we have a triangle ABC. Now we will draw bisector of angle BAC. Okay, you can see that here AD is bisector of angle BAC, and that bisector is perpendicular to side BC. You can see in this figure here ray AD is perpendicular to the side BC, correct? Now let's see the given part. What is given here? In triangle ABC, ray AD bisect angle BAC, correct? AD bisect angle BAC, and ray AD is perpendicular to side BC. To prove, we have to prove triangle ABC is isosceles triangle. So what is isosceles triangle? A triangle having two sides equal. A triangle having two sides equal is known as isosceles triangle. So what I am going to do to prove triangle ABC is an isosceles triangle, I have to prove two sides of this triangles are equal. Let's see the proof. So here we are going to prove triangle ADB and triangle ADC congruent. Okay, so in triangle ADB and in triangle ADC, look at this figure. Can you see this figure? Here angle A BAD, please see the figure. Angle BAD and angle CAD will be congruent, right? BAD and CAD will be congruent. Okay, angle BAD congruent angle CAD because ray AD bisect angle BAC. Correct? Why these two angles are equal? Because AD is a bisector of angle BAC. It's a given. Now look at this figure. Here side AD, okay, side AD is a common side of both the triangle. Okay, it is side of both the triangles. So side AD congruent to side AD, common side. Okay, and look at it in this figure. Angle ADB is 90 degree. Angle ADB is 90 degree. And angle ADC is also 90 degree because AD is perpendicular to side BC. So I can say here angle ADB congruent angle ADC because both have same measure, that is 90 degree. Therefore triangle ADB congruent triangle ADC. Okay, these two triangle will be congruent by angle side angle test. And we know that if two triangles are congruent, then their remaining parts will also congruent. Remaining part means remaining sides and remaining angles. So we will take here side AB of triangle ADB congruent to side AC of triangle ADC because of CSCT, corresponding sides of congruent triangle. So you can see that I have proved it here. Side AB and side AC of triangle ABC are congruent. Okay, and we know that if the two sides of any triangles are equal, then the triangle is an isosceles triangle. So I can say here, therefore triangle ABC is an isosceles triangle. Here we have question number 7 in figure. If seg P are congruent seg PQ, show that seg PS greater than seg PQ. Let's see the given part of this question. Seg PR congruent seg PQ, that is given. Okay, you can see in this question seg PR congruent seg PQ, it's given. And what I have to prove? Seg PS greater than seg PQ. Let's see the proof of this question. in triangle PQR. Please look at this figure. You can see that here side PQ and PR are congruent, right? Side PQ and side PR are congruent. It's a given. And we know that if two sides of any triangles are equal, then the angle opposite to them will also equal. So what are the angles opposite to those two equal sides? Please look at this figure. Angle Q and angle R. Okay, angle Q and angle R are the angle opposite to side PQ and PR. Therefore, angle PRQ congruent angle Q, according to isosceles triangle theorem, and it's equation number 1. Okay, look at this figure. Here angle PRQ is an exterior angle of a triangle PQR, and we know that measure of an exterior angle is greater than its remote interior angle. So this angle is exterior angle, and angle P and angle S are known as remote interior angle. Okay, and we know that exterior angle, that is PRQ, is greater than angle S. Angle PRQ is greater than angle S, according to property of an exterior angle of a triangle. It's equation number 2. Now in triangle PQS, okay, angle Q is greater than angle S. Okay, this we got from 1 and 2. You can see equation number 1. Equation number 1 says that PRQ and Q are equal. Okay, and equation number 2 says that PRQ is greater than S. If PRQ is greater than S, then Q will also greater than S, because Q and PRQ are equal. Okay, PRQ and angle Q are equal. So if PRQ is greater than S, then angle Q will also greater than angle S. Okay, and we know that if two angles of any triangles are unequal, then the side opposite to greater angle is greater, and side opposite to smaller angle is smaller. So here Q is greater. Okay, you can see here angle Q is the greatest angle, and here angle S is the smallest angle, and side opposite to greater angle is PS. So PS will be greater, and side opposite to smaller angle S is PQ. Okay, so PQ will be smaller. Okay, so which side is greater over here? PS. And which side is smaller over here? QP. So sec PS is greater than sec PQ. So we have proved it over here. Sec PS is greater than sec PQ. Now here we have question number 8 in figure. In triangle ABC, seg AD and seg BE are altitudes, and AE equals to BD. Prove that seg AD congruent seg BE. Let's see the given part of this question. In triangle ABC, seg AE congruent seg BD. What I have to prove? Seg AD congruent seg BE. Let's see the proof of this question. In triangle ADB and triangle BEA. Look at here in this figure. In triangle ADB and in triangle BEA, you can see here side AE and side BD are congruent. Okay, side AE and side BD are congruent. How we came to know? It's a given. You can see here seg AE and BD are congruent. Okay, so we can say here seg BD congruent seg AE. It's a given. Okay, now look at this figure. Here side AB. Okay, AB is a common side. It is a side of triangle ADB, and AB is side of triangle AEB. So seg AB is side of both the triangles, so it is a common side. And here seg AB is hypotenuse of both the right angle triangle. So here hypotenuse AB congruent to hypotenuse AB, since they are common sides. Okay, now angle, you can see in this figure, angle AEB and is 90 degree, and angle ADB is also 90 degree. So I can say here angle ADB congruent angle BEA. because they have same measure, both are 90 degree. Therefore triangle ADB congruent triangle BEA by hypotenuse side test. And we know that if two triangles are congruent, then the remaining part will be congruent. So remaining part we will take here AD congruent to BE, AD congruent to BE, CS, CT. Let's recap. Here we have two square of equal size. It means both the squares are congruent to each other. Here we have two rectangles of equal size. Therefore, these two rectangles are congruent to each other. Here we have two triangles of equal size. Therefore, triangle ABC congruent triangle PQR. So, figure having same size are congruent to each other. Here we have two circles which are unequal in size. Here we have two squares which are unequal in size. Here we have two triangles which are unequal in size. So here triangle ABC is similar triangle PQR. What are similar triangles? Two triangles are similar if and only if the corresponding sides are in proportion and the corresponding angles are congruent. Now we will try to understand similar triangles with the help of an example. Let's say example. Here we have two triangle ABC and triangle PQR. In triangle ABC and triangle PQR, look at this figure. Here angle A congruent angle P. Angle B congruent angle Q. You can see in this figure angle C congruent angle R. So all three angles of both the triangles are equal. And here AB upon PQ, you can see the value of AB is given 6 and the value of PQ is given as 3. So AB upon PQ equals to 6 upon 3 equals to 2 upon 1. Similarly, BC upon QR equals to 8 upon 4 equals to 2 upon 1. And similarly, AC upon PR equals to 4 upon 2 equals to 2 upon 1. So here AB upon PQ, BC upon QR and AC upon PR has same value, that is 2 upon 1. Therefore, AB upon PQ equals to BC upon QR equals to AC upon PR. So here we have two triangles whose corresponding angles are congruent and the sides are in proportion. Therefore, triangle ABC similar triangle PQR. Here we have question number 1. Triangle XYZ similar triangle LMN. Write the corresponding angles of the two triangles and also write the ratios of corresponding sides. So what is given here? Two triangles are similar. And what we have to write? Corresponding angles and ratio of corresponding sides. Let's see the solution of this question. Here we have two triangles XYZ and LMN. So what is given? Triangle XYZ is similar triangle LMN. First we will write pairs of corresponding angles of these two triangles. So look at this figure. Here angle X and angle L are congruent to each other. Why these two angles are congruent? How we came to know these two angles are congruent? You can see that the first letter over here in this triangle is X and here the first letter is L. Therefore, angle X is congruent to angle L. So we can write here angle X congruent angle L. Reason will come CAST, corresponding angle of similar triangle. Similarly, look at this figure. Here angle Y congruent angle M. Okay. How we came to know angle Y is congruent to angle M? You can see that the naming of this two triangle. Here the second letter is Y of this triangle and here the second letter is M of this triangle. So here we can say that angle Y congruent angle M. Similarly, you can see in this figure angle Z congruent angle N. Okay, the reason will come CAST, that is corresponding angle of similar triangle. So the first part of this question is over. It was asked to write pair of corresponding angles that we wrote. Next we have to write ratio of corresponding sides. Okay, so look at this figure. Okay, you can see here XY and LM are corresponding to each other, right? These two sides will be congruent, correspond to each other. How we came to know these two sides will be correspond to each other? Look at over here, the first two letter of this triangle. Can you see here in solution? XY. Okay, the first two letter of this triangle is XY and here the LM is the next first two letters of the next triangle. So XY will correspond to LM. Similarly, you can see in this figure YZ correspond to MN and XZ correspond to LN. So we can say that here XY upon LM equals to YZ upon MN equals to XZ upon LN. That is CSST, corresponding sides of similar triangle. Here we have the question number 2. In triangle XYZ, XY equals to 4 cm, YZ equals to 6 cm, XZ equals to 5 cm, and if triangle ABC is similar triangle PQR and PQ equals to 8 cm, then find the length of remaining sides of triangle PQR. Let's see the solution of this question. Here we have two triangles and you can see all the informations are mentioned in the figure itself. So what is the first step here? XY equals to 4 cm, right? YZ equals to 6 cm, XZ equals to 5 cm, and PQ equals to 8 cm. How we came to know? It's a given, right? You can see in the figure, I have noted all the informations. These two triangles are similar, right? Triangle XYZ is similar triangle PQR. How we came to know? It's a given. And we know that if the two triangles are similar to each other, then the ratio of corresponding sides of those two triangles will be equal. What would be equal? Ratio of their corresponding sides will be equal. That is XY upon PQ equals to YZ upon QR equals to XZ upon PR. Why these ratios are equal? Because of CSCT, because they are corresponding sides of similar triangle. Now we will substitute here the value of XY, YZ, XZ and PQ. Let's see what we will get. We will substitute the value. We will get here 4 upon 8 equals to 6 upon QR equals to 5 upon PR. Okay, you can see I have substituted value of XY, YZ, XZ and PQ. Okay, so we will consider here 4 upon 8 equals to 6 upon QR equals to 5 upon PR. We will consider as equation number 1. Now we can write here 4 upon 8 equals to 6 upon QR. How we got this? From equation number 1. You can see in the equation number 1, 4 upon 8 equals to 6 upon QR. Now we will simplify this further. So what we will get here, 4 into QR equals to 6 into 8. Now we will shift 4 to that side. So we will get here QR equals to 6 into 8 upon 4. Now we will do the cancellation. We will divide 8 by 4. So 4 2s are 8. So what you will get in the numerator? 6 into 2. So QR equals to 12 centimeter. Similarly, 4 upon 8 equals to 5 upon PR. You can see the equation number 1. 4 upon 8 is equals to 5 upon PR that we got from equation number 1. Now we will go for cross multiplication. So we will get here 4 into PR equals to 5 into 8. Now we will shift 4 to that side. So PR equals to 5 into 8 upon 4. Now we will do the cancellation. We will cancel 8 by 4. So 4 ones are and 4 twos are. So what we will get in the numerator? We will get 5 into 2. So PR equals to 5 into 2, that means 10 centimeter. So PR is 10 centimeter and QR is 12 centimeter. Here we have question number 3. Draw a sketch of a pair of similar triangles. Label them. Show their corresponding angles by the same sign. Show the length of corresponding sides by numbers in a proportions. So here we have two triangles and we have labeled those two triangles. I have named those two triangles as ABC and PQR. What is the next step over here? What is asked next things over here? Show their corresponding angles by same signs. Okay, so look at this figure. Angle A and angle P got a same kind of sign. Okay, angle A and angle P have same sign. So it means angle A congruent to angle P. Similarly, angle B and angle Q also got the same sign. So it means angle B congruent to angle Q. And angle C and angle R. You can see in the figure angle C and angle R got a same kind of mark. So the first part is over. It was asked to show their corresponding angles by same sign, that we have done it. Next it is asked to us write the length of, show the length of corresponding sides by numbers in a proportion. So what we are going to do, we are going to put here some length to all the sides of those two triangles such that their sides should be in proportions. Look at over here in this figure. Here I have taken AB as 6 and PQ I have taken as 3. So what is the ratio of these two sides? AB upon PQ equals to 6 upon 3 equals to 2 upon 1. You can see that I have done the calculation. I have calculated the ratio of those two sides. What we got here? 2 upon 1. Similarly, I have taken BC as 8 and QR as 4, such that the ratio of these two sides should also be 2 upon 1. Okay, so look at over here. BC upon QR equals to 8 upon 4 equals to 2 upon 1. Similarly, we will take here the length for AC and PR such that the ratio of those two sides should also be 2 upon 1. So you can see here I have taken AC as 4 and PR as 2. So AC upon PR equals to 4 upon 2 equals to 2 upon 1. So here all three ratios have same value, that is 2 upon 1. Therefore, AB upon PQ equals to BC upon QR equals to AC upon PR. It means the ratio of corresponding sides of those two triangles are in proportions.